Hello friends, welcome to Awdhesh Academy. Today we are going to start the third chapter of class 11th physics, and the name of the chapter is motion in a straight line. Now this is a very important chapter because once you know and once you understand this chapter, motion in a straight line, then you can deal with the more complex topics like motion in a plane. So today we are going to take the first lesson of this, and that is about position, path, length and displacement. So let's understand the concept of motion. The motion means when one object moves from one place to another place, one position to another position, that is called motion. Now this chapter is also called kinematics because in the kinematics we understand only the motion and not the forces or the reasons why this motion is happening. So we are going to learn about the motion in a straight line, and I will explain the different concepts of position, displacement and path length. Let us first understand the position. The position of a particular point is usually expressed in three-dimensional space: length, width and height. This is also represented as x, y and z. So any point in this space can be expressed in terms of three coordinates: x, y and z. So suppose this is the point P, and we say the point is equal to 1, 1 and 1, then it means 1 in the x direction, then 1 in the y direction and 1 in the z direction, and this is how we will get some point here. And this point is generally called origin, and this is an arbitrary point, we can take it any point, and this is called origin. So by this way we can mention any point in the space. Now in order to mention time, we put a clock and we measure the time from time 0. So when we put the three-dimensional space and the time together, then this is called frame of reference. In this chapter we are dealing with rectilinear motion. That means motion in one single straight line. Now the motion can be in two directions, plus and minus. Let us understand that. Let us say that we represent this particular straight line, this as the origin. This is a hypothetical origin point. In this direction we are saying positive direction, and in this direction it is a negative direction. So if suppose we move on this direction, it is called positive. So suppose if we move up to here, it is plus 10. And if we move on the opposite direction, it is called minus 10 and it is the negative direction. So this way, whatever direction we have covered on this side, this is called positive, and whatever distance we covered on this side is called negative. So the first important concept we have to understand in this chapter is path length. What is path length? Path length is basically the distance covered by an object from one point to another. This is simple path length. So let us say you start from this point and you cover say 20 meter distance here. This is path length is 20 meter. Now let us say from this point you turn back and you come here again to minus 20, and thereby you covered 40 meters of distance. Then the path length will be 20 plus 40, so path length will be equal to 20 plus 40. So you can understand that this path length is basically a scalar quantity because it only mentions the dimension. There is nothing like plus or minus. Whether you cover on this direction first or whether you cover on this direction first, it does not make a difference because it is just a quantity. There is no dimension attached to that. So you cannot say that the path length is minus 20 because it has moved in the negative side, or the path length is plus 20 because it has moved in the positive side. Path length is always positive. This is an important thing to remember. And this is the total distance which a particular particle cover in the given period of time. So we have already learned about the path length. Now we are going to learn about the displacement. What is displacement? Displacement in a simple term means the net change in the position. So in the mathematical term, we can say that delta x, which is displacement, is equal to x2 minus x1. That is the second position and the first position. So let us take an example. For example, if you are here and you move to a position here, that is move 20 meters on the this side, right side, on the positive side, in that case the value of the x2 become 20 and the value of x1 is 0. And so if you have to calculate the displacement, the delta x will be equal to 20 minus 0, and that is equal to 20. Now imagine that instead of moving on the positive side, we have rather moved on the negative side, and this become our second point. So x2 value will be minus 20, and so if we calculate delta x now, it will be minus 20 minus 0, and that is equal to minus 20. So you have seen that the displacement is always having a dimension. The dimension can be either positive or it could be negative. So in one case it was positive, the other case it was negative. But if we calculate the path length is going to be always positive. In both the cases it will be 20, but as far as the displacement is concerned, it will be plus or minus. Now let me give you one more example to explain how the path length and the displacement are two different things. Now let us say, for example, from here, point 0, we have travelled to a distance of 20, and thereafter we have travelled a distance of 60, and finally we have reached to this position, which is equal to minus 40. Now if you are talking about the path length will be 20 plus 60, and therefore path length will be equal to 20 plus 60, and that is equal to 80. However, when we are talking about the displacement, we have to see this is x2, and the value of the x2 is minus 40, while the value of x1 is 0, and therefore the displacement will be equal to minus 40 minus 0 and equal to minus 40. So we have seen that in the same case the path length is 80, while the displacement is only minus 40. Because displacement is a vector quantity, it can be plus or minus, and it ultimately matters what is the final position of the particle vis-a-vis the first position, and that is what is going to decide what is displacement. So we have understood what is path length, we have understood what is displacement, and now we are going to understand how we can represent a movement of a particular particle or an object in the form of graph. So this is called a position time graph. Now here we see three graphs which I am going to explain to you. Let us take the first graph. In the first graph, the distance is or the position is represented in the y-axis, and the time is represented in the x-axis. So we see that the time is 10 second, 20 second, 30 second, 40 second, 50 seconds, and the distance is 20 meters and 40 meters. Here we see that while the time is moving, but the position of the particle is same. That means it continue to be on only 40 meter. What does it mean? It means that the particle is not moving, the object is not moving. So this is a graph of stationary object. Now let us take this second graph. In the second graph, we see that as the time is moving from 10, 20, 30, 40, the position is also moving. So for example, when it was at 20 second, it has moved to 20 meter. When there was 40 second, the particle has moved to 40 meters. So this is how it is moving at the constant speed, and that is why this is showing as a straight line. If you want, we can measure the velocity also. And how we measure the velocity? Because velocity is equal to the change in the distance and the change in the time. And therefore, if suppose we say the distance here is 40 and the time change is also 40, and so we can say that the velocity is equal to 1 meter per second. Now come to the third graph. In the third graph, we see that initially the position does not change with time. So it remained at 0 even though the time has moved to 10 seconds. That means this object was stationary. Thereafter what happened, that it has gathered speed and it has moved say up to 40 seconds, and thereafter again it has become stationary. That means this is basically stationary, then there is a movement, and then it is again stationary. This is typically a movement of a car. When a car is not starting, it does not start, it is stationary, and this is the portion before the car has started. Then this is the position where the car has moved, and again this is the position when the car has started, because here again it has become horizontal. So through this three diagram, I have tried to show you that how we can represent whether the particle is moving, whether it is moving at the same speed, or whether it is moving at the different speed or velocity. So this is the three representation, and we shall discuss this thing further when we are going to discuss about the velocity and speed. So in this lesson, we have learned about position, path length, displacement, and time position graph. These concepts will be used in the subsequent lessons when we are going to talk about velocity, speed and other things of this chapter. Thank you.